Hi there. Today I'm going to talk about and explain properties and characteristics of light when it reflects off curved mirrors. There are two types of curved mirrors that we're going to talk about. One is called a concave mirror and the other is a convex mirror. Don't forget, let's review. We have learned about what happens to light as well as images in plane mirrors. Plane mirrors are flat. So light bounces off or reflects off a flat mirror and the normal line is drawn and this angle and this angle are equal to each other. What about an image? Like this chess piece. Well, what can we say about the image? The image will be upright. We call that its attitude. So it'll be virtual and it will look the same size and the same distance in the mirror. The only thing different about it is left and right are reversed. Curved mirrors. We're going to use a ray box which sends out a straight beam of light to see how reflection works in a curved mirror. As I said before, there are two types of curved mirrors. We have concave mirrors, which cave inward. So this is a concave. And we have a convex, which is curved outwards. And there's important terms that we should be familiar with. The center of the curvature we call C, and that's the center of the original sphere. The radius of the curvature is the distance from the center of the curvature to the mirror. The vertex is basically the center of the mirror right here, the vertex. Vertex right there. Vertex right there. The principal axis is a line drawn through C and V. So here's the principal axis right there. And V would be right there where my pen is. The primary focus is F, and that's where all the lights, all the rays converge or meet. And the focal length. So let's talk about what might happen with curved mirrors. Here's a girl, let's call her Melissa. And if it's a flat plane mirror, what would we notice? She'd look the same except left and right would be reversed. However, what about in a curved mirror? So again, here's what a concave mirror is, and here's a convex. So here's Melissa. What would she look like in a curved mirror, like a convex? Would she be shorter and kind of fatter? Would she be taller and thinner? I know we may have all been to a house of mirrors, and they always have different shapes of the mirror to make us look unusual. Well, let's consider this. We can draw ray diagrams to see what's going on. Here is a concave mirror, and here is an arrow, which is our object. Another name, just to let you know, for concave mirrors is converging mirrors. When objects are far away, like this, from a concave mirror, what will happen? Well, there's the light rays go like that and like that. And here's what would happen. We would get an image upside down is what it would look like. If the object was a long ways away from the concave mirror, it would look upside down and it would look smaller than the original object. How about a convex mirror? Okay, here's the image, the rays of light bounce off, and what would happen? We'd get a virtual image. It would look smaller, but what do you notice about the distance from here to here compared to the distance here to here? It's closer. So convex mirrors usually make objects smaller in appearance, but they are closer. Our side mirrors on our vehicle, on the outside, the two side mirrors of the vehicle that attach close to the window, are usually convex mirrors, and there's usually a little notice or a warning sign on these that say objects in the mirror may appear closer, and that's why it's a convex mirror. How about a concave mirror, but this time close up? What will happen then? Well, now the image is going to be virtual. It's going to be right side up, not upside down, and it's going to be much larger or magnified. Here's a convex mirror again, sometimes called diverging mirrors. As I said before, what happens is the following. Here's the arrow. The beams of light bounce or diverge away. The image that you're going to see is a lot smaller, but notice again how close it is. So watch what happens. Rays diverge, they bounce off. It creates this image, this virtual image, which is a lot closer or appears to be a lot closer in the mirror, but smaller. Here's a lady. Makeup mirrors are what kind? Makeup mirrors are concave. So a concave mirror, like this makeup mirror, will make the image a lot larger when you're close up. Okay, it only works if you're close up though. Here's a concave mirror, and here's the real image. Here's what he would see in the mirror. Okay, notice how much bigger the image is right side up and it's magnified. So concaved are curved inward. Light rays strike and they make the image larger. Here it is again. Here's our arrow. This is the focus, the focus where the light rays can all come together. They converge here at the focus. And this is our principal axis. And notice the virtual image. A lot bigger because we're close up. Close up to what? Close up to a concave mirror. So in general, properties, if the object is close to the mirror, closer than the focal point, which is here, so if the object is closer than the focal point, the image is virtual. It's upright and it's magnified. How about far away? So here's our object. This time the focal point's right here. That's where all the rays meet or converge. What will happen? Here's the rays. They bounce off and converge here. And where's our image? Right there. So the image will be smaller, but upside down. So if we put an object outside the center of a concave mirror, we find the image is real now, in the sense that the light rays pass through it. It's inverted or upside down, and it's smaller. So here's a little summary. These are all numbers representing real images, and the blue correspond to what the image would look like in the mirror. So if you were far away, like number 1, from the focus, what would that do in the mirror? That would create this, a smaller inverted image. But as you get closer, here's number 2. Let's move it a little closer. What do you notice? It gets a little bigger. Move it closer. Now it's right there. Look at the virtual, or it's not virtual because it would be on this side. Look at the real image, the real image. This is the real object, this is the real image. It's the same size, but upside down. Let's get closer to the focus, and now look. 4, it's still real, it's inverted, but it's bigger. Look at number 5. It's getting a little closer to the focus, and look at how big it is. Now, if we're inside the focus, like number 7, look what number 7 looks like. Magnified. However, we can't get too close. If we get too close, look at 8. Okay. If this was number 10, let's say number 10 is here, which means it's closer to the focus, but still to the right of the focus. Here's what 10 would look like. 10 would be even bigger than 7. That's what 10 would look like. So when you use a makeup mirror, which is a concave mirror, close up, you don't want to get too close because number 9 is really close, and look what it looks like in the mirror. The same. And so that's a quick summary of convex and concave mirrors.